Hi dear students, this is Srinu, MSc BEd, Faculty of Mathematics, Akshar IIT Foundation. In this session, I would like to discuss with you some basics and concepts we have chosen a topic called real numbers. Shall we start? Here we go. So welcome to Akshar IIT and NEET Foundation courses. We are dealing with subject mathematics. So real numbers. We know that real numbers are the combination of rational and irrational numbers, right? Yeah. So before we go to rational and irrational number, let us see some more numbers, some more sets of numbers. Can you guess? Yeah, you are right. Natural numbers, whole numbers, integers and all. So let me write on the board. So before we go to rational and irrational, natural numbers, whole numbers and integers. The set of natural numbers denoted by the letter N and whole numbers by W and integers by Z or I. So as you know, so natural numbers starts with 1, 2 and so on, unlimited, and whole numbers join 0 to the natural numbers, then we get whole numbers. So 0 is the smallest whole number, so unlimited number of terms. And integers, how do we get integers? Yes, you are right. So we will take number line here and at the middle 0, and right side I will write 1, 2, 3, 4 and so on, and I will write images, negative images of these numbers, -1, -2, -3 and so on. If I take 0 as the mirror, right, so that we will get and so on at some negative infinity to -1, -2, -3, 0, 1, 2, 3 and positive infinity. So these set of numbers right from 6th class or 4th class we are learning. Then let's enter to rational and irrational numbers. So let us connect these three set of numbers to rational and irrational numbers. See. So just now we discussed natural numbers, and if I add 0 to the natural numbers, we will get whole numbers. And negative numbers, if I add negative integers or negative numbers, negative counting numbers to whole numbers, we will get integers. Then what about rational numbers? So this all together we can take or call rational, and there is a separate set is irrational. Of course, rational numbers denoted by the letter Q and irrational denoted by the letter Q dash. So all together we will call, yes, yeah, real numbers. We can call it as real numbers R. Right? Now let us define the correct definition for rational numbers. Okay. Yes. So rational numbers, generally we can say it is in the form of P by Q. Right from 6th class we learn form of P by Q, and Q should not be 0, and P comma Q are integers. P comma Q are integers. That means rational number is a fraction. That means only fractions are rational numbers, or any other numbers are also rational numbers. Yes, you are right. Natural numbers, whole numbers, integers are also rational numbers. How can we conclude this? Let me explain. So as I said here, a rational number should be in the form of a fraction. Numerator and denominator should not be equal to 0, right? Then I will take a natural number 5. I will take a whole number -0, and I will take an integer -3. And I have to conclude that natural, whole and integer, all these three sets are also called rational. How can we? Let me. So 5 I will write as 10 by 2. Do you agree? Yes, you are right. And 0 I will write as 0 by 5. 0 by any number is 0. And minus 3 I will write as minus 6 by 2. Observe here. So this is in the form of P by Q, this is in the form of P by Q, and this is also in the form of P by Q. So 10 by 2, 0 by 5, minus 6 by 2 are in the form of P by Q. And also Q not equal to 0. Here denominator is not 0. Denominator is not equal to 0. And P comma Q, these are integers. So we give a conclusion. All the natural numbers, whole numbers and integers, you can say they are rational numbers. Okay. Next. So what about irrational? So rational number I gave an example and definition. Irrational numbers are denoted by the letter Q dash, and the number which cannot be written as in the form of P by Q. Either true or false. True is rational and false is irrational. Can be written is rational, cannot be written is irrational. Okay. And here Q not equal to 0, P comma Q are integers. So what kind of numbers we cannot express in the form of P by Q, in the form of fraction? Let me take a number, root 2. Root if I take, you know the value of root to 1.414, 213 and so on. So if I take root 2, just now we have discussed, 5 can be written as 10 by 2, and you may say that root 2 also can be written as 2 root 2 by 2. We got a fraction here. So is it a rational? No, it's not a rational. And there is a condition. What is that condition? If I cancel here, I will get root 2 by 1. Of course, denominator is not 0, but what about the numerator? What about the numerator? Yes, they are integer. P comma Q are integers. P comma Q are integers here. Here, truly, root 2 is not an integer. Root 2 is not an integer. So, we can't say root 2 is a rational. Root 2 is irrational. So P and Q should be integer. Q not equal to 0 and P comma Q are integers. Hope you are following, right? So now, terminating and non-terminating, some different types of expressions in the rational numbers we will see now. Let me check. So decimal representation of rational numbers. What is decimal representation of rational number? So rational number can be expressed as in the form of P by Q and the Q not equal to 0. Q not equal to 0 and P comma Q are integers, right? So suppose if I take 3 by 2 and 1 by 3. 3 by 2 and 1 by 3 both are rational numbers because the denominators 2 and 3 are not 0 and 3, 2, 1, 3 are integers, right? So these are rational numbers. So the rational numbers can be expressed in the decimal forms. So what kind of decimal forms are said to be rational number? This is our question. What type of decimals are said to be rational numbers, right? So let us clear about it. So I will write some decimal forms. What we have seen in our earlier classes or according to our previous knowledge. I will write some decimals here, 1.5675, 25.6789 and 25.666666 and so on. And some more I will write 13.125, 125, 125 and so on. And I will also write 15.67 bar. Please check these decimals. So first one is after decimal we are having some limited digits. So obviously we can call it as terminating decimal. This is a terminating decimal. And this is also end up. There is no and so on here. This is also terminating decimal. And what about this third one? Here we have given and so on. There is no end. 6 is repeating or recurring. So these kind of decimals we can name as non-terminating recurring decimals. Non-terminating recurring decimal. 6 is recurring or repeating. The same will come here. 13.125. You can take a bar over there and 125 is repeating. So non-terminating recurring decimal. And this is also non-terminating recurring decimal. So according to these examples, we can give some conclusions. What are the conclusions here? Terminating and non-terminating recurring decimals. Terminating and non-terminating recurring decimals are called as rational numbers. So rational numbers can be expressed into two types of decimal representation. The first one is terminating decimal and the second one is non-terminating recurring decimal. So let us do some divisions. So just before I gave an example, 3 by 2. 3 by 2 comes under what type? 3 divided by 2, I will go with 2 ones and I will take the decimal. You might be known the decimals, divisions and all. 5 2s are 10. So here I got 1.5. 1.5 is a terminating decimal. I go to 1 by 3. So I will check 1 by 3 here. Divide 1 with 3. So we can't divide 1 with 3. We have to take decimal. Then 0. 3 3s are 9. Here 1. Again I shall take 0 and 3 3s are 9. 1. 3 3s are 9. 1. So what is repeating here? 1 is repeating. So it is a non-terminating recurring decimal. So here remainder 1 is repeating. But in the quotient place, what is repeating? That is important for us. 0.333 and so on. 0.3 bar. So 3 is repeating. 3 is repeating. So this is non-terminating recurring decimal. This is terminating decimal. So these kind of decimals we can represent or we can say as rational numbers. So we can say this is a decimal representation of rational numbers. So what kind of decimals are called as irrational numbers? This is our question. So terminating and non-terminating repeating decimals are called, non-terminating recurring decimals are called rational. Then what about the irrational? Just now we have seen an example. Root 2 is equal 1.414213 and so on. What is the name we are giving there? Can you guess? Yeah. Non-terminating, non-recurring decimal. Let me write on the board. Non-terminating, non-recurring decimal. Non-terminating, non-recurring decimals are called as irrational numbers. You can call them as irrational numbers, right? So this is another name or another definition for an irrational number. For rational number, another definition is terminating and non-terminating recurring. An irrational number, another definition in the form of decimal is non-terminating, non-recurring decimal. Let me write an example here. I give an example. Yes. 1.41421356780 and so on. See this example. So 1.414, no particular period is repeating here. 414213567801005 and so on like that. So no particular digit or no particular number is repeating here. So these type of decimals we can call as irrational numbers, and we are giving non-terminating, non-recurring decimals. Non-terminating, non-recurring decimals are called as irrational numbers. Right. So next, there are some types of decimals. So in non-terminating recurring decimals, we can classify into two kinds again. Terminating we can't classify, but non-terminating recurring we can classify. So let me check this once. So non-terminating recurring decimals are classified into two types. I will write the example, then after we conclude it. Okay? See. So here in an example I will write 1.5 bar or 20.6785 and so on. So we will write it as 20.6785 bar. This is repeating. And here I will take an example like 20.215555 like that I am writing. That means we will write 20.215 bar. 5 bar. So what is the main difference between this example and that example? Right here, you see carefully, decimal after particular bar or particular digits are repeating 6785 to 1 point. So I write like this 20.6785 bar and 20.215 5 bar. See the difference. After decimal, all the digits are repeating. But here after decimal, some particular digits are not repeating. After some particular digits, we have a repeated numbers. Right? Here there is a 21. Here 21 is not repeating. After 21, after two digits, we are getting the repetition of 5. Here immediately after the decimal, we have the repetition. We have the recurring. So we got the clarification now. So non-terminating recurring decimals can be classified again into two types. One is mixed and one is pure. Pure in the name itself we have. Pure in the sense total. Totally we have the decimal bar. And here mixed, some decimals, some digits after we have repetition of the numbers. Hope you're following. So this is all about the decimal representation of rational numbers, terminating, non-terminating, recurring. Again, non-terminating, recurring we can classify into two types, mixed and pure. So let's move on to another topic, non-terminating, non-recurring. So just now we discussed non-terminating, non-recurring are also called as irrational numbers. Non-terminating, non-recurring decimals are also called as irrational numbers. I already explained for you. So irrational numbers are denoted by the letter Q dash and 1.41421356780 and so on. Okay. So non-terminating, non-recurring. Right. Non-terminating, non-recurring decimals. So in this session, what do we learn? So what is a rational number? So what type of numbers we can call as rational numbers? And decimal representation of the rational numbers. Decimal representation of the rational numbers, and in rational numbers we can classify decimals we can classify into three types: terminating, non-terminating, recurring, non-terminating, non-recurring. So terminating, non-terminating, recurring we can call as rational numbers. Non-terminating, non-recurring we can call as irrational numbers. Okay. And then why do we call Again, in non-terminating recurring decimals, we have two kinds, pure recurring and mixed recurring. This is all about the fundamentals based on these real numbers and rational numbers and irrational numbers. Why do we learn these all fundamentals and basics? We can go directly to the problems. No? What is the need of learning this definition of a rational number, definition of an irrational number, definition of a mixed? So sometimes the question will be given like this. How like? So there is a question. So 2 plus root 3 plus 2 minus root 3 minus 2 plus root 3. This is the question. Simplify. The options are like this. Options are option A, rational number. Option B, non-terminating, non-repeating or non-recurring decimal. Non-recurring decimal. And option C, integer, because integer and rational number both are same. And option D, 0. Okay, let us see these options. So now answer is given like this. Answer is given, or options are given based on the fundamentals, based on the concepts. So we shall learn basics and fundamentals, and we should have some grip on these fundamentals. Otherwise, we can't attempt any competitive examination. So let me do this question. So what is the answer I will get? I will see now. 2 plus root 3 plus 2 minus root 3. Here I remove the minus and I have to change the signs of the terms which are present inside the bracket. It will come like this. Now what are the cancellations here? Here I go the cancellation with 2 and 2 and root 3 and root 3. So finally what did I get? 2 and minus root 3 I got. 2 and minus root 3. So is equal to 2 minus root 3. So what can we say about 2 minus root 3? So let us check the options. It is not a rational. Why it is not a rational? Because irrational number is present. Just now we have discussed root. Root is furtherly not simplified. It is a prime number. Is a irrational number. See 3 we can't simplify furtherly. And 16 we can simplify. 4 4s are 16 can be expressed as product of 2 prime factors. A product of 2 numbers. Here I would like to give a small conclusion for you. Small clarification. Let me check once. So let me erase this. So root 2, root 3, root 9. There are 3 numbers here. So what is the difference between these 3? So root 2, I don't know the value of root 2. I don't know the long division method. I do not know how to simplify, how to get the values of root 2. But root 9, root 3, then we know the multiplications. How to express a number product of 2 equal factors. Right? I know how to express 9 as 3 into 3. I know it. But 13 I can't. And 2 also I can't. So 9 can be expressed as product of 2 equal factors. 13 cannot be expressed as product of 2 equal factors since it is a prime and it is under root. 2 is a prime and it is under root. The prime number which is having square root also called as an irrational number. Right? Now we got some more clarification about irrational number. So after dividing and all, not directly also we can say whether it is a rational or irrational number. So let us come to our question. Root 3 can't be expressed as product of 2 equal factors. So it is an irrational number. 2 is a rational. 2 minus root 3, rational minus some irrational. What can I subtract from 2? I don't know the value of root 3. Obviously we get irrational only. So your answer we get irrational only. But where is the option? Rational, integer, 0. These 3 are wrong. Then finally we go for non-terminating, non-recurring decimal. Non-terminating, non-recurring decimal is nothing but irrational number, right? So that we must be perfect in basics, fundamentals and all our regular and traditional concepts and methods. Then we shall learn the next level of learning what we are doing here, that is IIT Foundation. Hope you're following. We shall continue the next class. Thank you.